My check engine light is on, the amber warning light. It is a universal experience for modern drivers, a moment that often occurs without any fanfare or dramatic noise. You're driving down the highway, navigating the morning commute, or heading out for a weekend trip when a small amber colored icon illuminates on your dashboard, and it is the outline of the engine block, sometimes occupied by the words check engine or service engine soon. And for the the vast majority of vehicle owners, this light triggers an immediate sense of unease, and it should. Unlike the low pressure oil light or the battery charge warning light, which indicates specific and often immediate mechanical failures, the check engine light, technically known as the Malfunction Indicator Lamp, or MIL, is notoriously vague. It offers no explanation of the problem, no estimate of the severity, and no instructions on how to proceed. Is the car safe to drive? Is the engine about to fail? Is it simply loose gas cap? And bluntly, tighten your gas cap. I mean, it just creates a lot of stress and pressure and everything if we don't tighten the gas cap. It takes 1 extra second, not even 1 extra second. You're already putting the gas cap on, tighten it till it goes click. The ambiguity often leads to two distinct reasons. Some drivers panic, pulling over immediately and fearing the worst. Others, perhaps desensitized by previous false alarms, choose to ignore the light entirely, hoping it will simply vanish on its own. Neither approach is ideal. The light is not a random annoyance. It is a sophisticated communication tool from your vehicle's onboard computer. Understanding how the system works, what triggers the warning, and the importance of the professional diagnosis can transform that anxiety into informed decision making. So, I mean, unfortunately, I've been in the automotive business a really long time, and so 1981 is when the first onboard computers were rolled out, as a group. 1974 is when the electronic ignition came out, and we started seeing the end of the points and condensers and all kinds of stuff like that. The evolution of the current model that we're using started in 1996. The OBD2, so the onboard diagnostics generation 2, started in 96. So and it's evolved. I mean, it's evolved so much it's not even funny. And you have government regulations that's making it evolve. Manufacturers, think about it. Car manufacturers don't want to put a bunch of extra parts on your car. It's not in their best interest to put a bunch of extra parts on your car. But they have government regulations that says that we have to conform to these guidelines. And these guidelines, the only way that we can achieve them is by putting a bunch more stuff on your car to achieve those guidelines. And the OBD2, the onboard diagnostic generation 2 has evolved into it's crazy. It's literally a rolling network of computers. And your engine control unit, ECU, or powertrain control module, PCM, act as the central brain. It receives constant streams of data from dozens of sensors that monitor everything from ambient air temperature and barometric pressure to the speed of the crankshaft and the oxygen content of the exhaust gases. The ECU processes data thousands of times per second, making micro adjustments to fuel delivery and ignition timing to ensure the engine runs as efficiently and cleanly as possible. Thousands of times per second. Think about And you've got so many onboard computers, modules in your cards, 10, 20, 30, 40, 50. So, and 3, 4 miles of wire in your car. And again, dozens and dozens of sensors. Um, and they're positioned everywhere. They're literally positioned everywhere, and your check engine light, steady versus flashing. The steady, you know, it, it definitely says bring the car in. Flashing means bring the car in now. So if you had a steady check engine light, it's a big deal. It is. I mean, because it can basically some of the weird stuff that my technicians have told me over the years. It goes into limp mode, which means it goes back to the best known setting for it. Well, if the best known setting for it at that specific time happened to be that you're running really super rich, well, then you're now running super rich and you can destroy all kinds of stuff running rich. Or it might be running lean, which means it's going to be even worse than rich because, now you're starving that motor and you're creating havoc inside of that engine. It might be that you got lucky and it's a good happy between the two of them. But the reason that you can be lean and rich is, when you start your car first thing in the morning, depending on how cold it is. Back in the old days with a carburetor, you would push the gas pedal down, really hard, and that would make the butterfly at the top of the carburetor flop over. And when it flopped over, that means that it's now getting way more gas than air, so it was running super rich. Well, you have a temperature control sensor now that tells the computer what the temperature, the ambient temperature is, and based on the ambient temperature, then the computer is the one that's adjusting the air to fuel mixture, and of course it's richer first thing in the morning to get it moving. And then once it heats up, once the engine warms up, then the coolant temperature sensor is sending that signal to the computer, and the computer then is adjusting the air fuel mixture based on the temperature of the existing motor at that point. So it's an amazing thing. And then of course it's got oxygen sensors reading how much unburned gas you have going into your exhaust. And it's making adjustments based on that. I mean, the things that your engine is doing literally thousands of times per second is just unbelievable. I mean, like the oxygen sensor. It is definitely sending the signal, whether you're rich or lean, constantly. I mean, and if you have a lazy or failed O2 sensor, it's definitely the engine is not going to run, very effectively at all. And it can significantly lower your gas mileage. And it can definitely ruin all kinds of stuff. And then you've got like the catalytic converter. And this is an environmental device that, I mean, no manufacturer wanted to put this bad boy on there. Creates back pressure, all kinds of stuff, So you've got the EVAP system, the evaporative emissions system, and it's, you've heard of the advice of tighten your gas cap, which I just gave you. Well, the EVAP system is a closed system. And gasoline's volatile and it evaporates easily. The evaporative system it's sealed. It's designed to keep the gas inside of the car. The fuel vapors from that's why you're not smelling gas when you're standing beside where you put the gas in at. And then you've got like the mass airflow sensor, the MAF. Again, we need the air fuel mixture, so the computer is definitely gauging how much airflow you got going through. And then you've got your spark plugs and ignition coils. And then you've got thermostat issues as far as keeping the engine, whether it's going to overheat or keep it running at the right temperature that it's supposed to. And then you got the exhaust gas recirculation valve, the EGR valve. You got transmission controls. You got vacuum leak. There's not near as many vacuum lines as there used to be, not by any stretch, but you still got a bunch of vacuum lines running around in your car. You got fuel injectors, okay? But the problem is that some of the companies out there have decided to do free code scans. Well, the code's not a it's not a diagnosis. The code is just sent you, it gives you a, like an example, a code PO 171. System is 2 lane, bank 1. This means the O2 sensor is telling the computer that there's too much air and not enough fuel in the mixture. A novice might see this code and immediately replace the O2 sensor. However, the O2 sensor is likely working perfectly. It's accurately reporting a lean condition. The actual cause could be a vacuum leak, a clogged fuel injector, a weak fuel pump, or a dirty, MAF sensor, mass airflow sensor. Replacing the O2 sensor would be a waste of resources that fails to fix the problem. So you definitely need to bring it into the shop. You definitely need to find a shop that you trust, build a relationship, and a relationship works both ways. And they're going to definitely they'll do code retrieval and freeze frame analysis. They're going to do live data monitoring. They're going to do fuel trim analysis. They're going to do pinpoint testing with smoke machines, bidirectional controls, oscilloscopes. They're going to verify. This is a big deal. It's a way bigger deal than most people even began to hope or dream that find a shop that can take care of your car, build the trust. And you need to be able to trust your vehicle. Most people, back when I was a kid, we didn't trust our vehicles because we couldn't. The reason that we couldn't is because they weren't built. They just weren't. And points and condensers and carburetors. I mean, you were in the shop with those cars back then. You were in the shop 10, 12 times a year. No exaggeration. Now, if you have to go to the shop a couple of times a year, it's like the biggest inconvenience in the world. Well, you might want to change your mindset on that. You might want to go in and see your shop 3 or 4 times a year on purpose so that they can keep up with what's going on in your car. I mean, most people are driving 15,000 miles a year on average. That's every 4 months, every 5,000 miles you're going in. And if it's always by time or mileage. So preventative maintenance makes it to where, no shop can catch everything before it fails, but preventative maintenance can make it to where a lot of things don't fail to begin with. So you just got to know that. Stay safe, stay strong.